Hi, so this is a presentation on radio wave propagation. And before learning about radio wave propagation, let's take a look about what are radio waves. So, radio waves are simply electromagnetic waves that have a wavelength of 1 millimeter to 10,000 kilometers and a frequency of 30 hertz to 300 gigahertz. So, as compared to other electromagnetic waves like microwaves and visible light or even infrared, radio waves have a comparatively larger wavelengths. And like all electromagnetic waves, radio waves have perpendicular components of both electric and magnetic field. Like we know that in EM waves, electric fields and magnetic fields travel perpendicular to each other, and radio waves are no different because they are just a part of the electromagnetic spectrum. And of course, they travel at the speed of light and has the same properties with respect to reflection and diffraction. When passing through a material medium, they are slowed down. Which means radio waves are slowed down according to that object's permeability and permittivity. Air is thin enough that in the Earth's atmosphere, radio waves travel very close to the speed of light. Uh, it is saying that in the atmosphere, the the refractive index is not high enough so that the speed reduces considerably as compared to the speed of light. The speed is very comparable to the speed of light. And now start the radio wave propagation. There are three modes of propagation of radio waves: ground wave, sky wave, and space wave. The ground wave propagation. There are 4 points about the ground wave propagation. They progress along the surface. They are used for short range communication. Attenuation, which means the loss in energy of the wave occurs because it induces current in the ground. It is saying that the ground waves, when they travel, they induce current in the ground, and through diffraction also the attenuation of the wave occurs. They are also called surface wave propagation. Ground waves progress along the surface of the earth and must be vertically polarized to prevent short circuiting the electric component. A wave induces current in the ground over which it passes and thus loses some energy by absorption. This is a diagram which shows how the wave tilts when it travels over the surface of the earth. Of course, the surface of the earth is tilted, it is curved, so the wave tilts at each curvature of the earth. And as we are seeing, these are the successive wave fronts, and the angle of tilt keeps on increasing, and through diffraction the wave loses its energy. There is another way in which the surface wave is attenuated because of diffraction. The wave the wavefront gradually tilts over as shown in the previous figure. As the wave propagates over the earth, it tilts over more and more, and the increasing tilt causes greater short circuiting of the electric field component of the wave and hence field strength reduction. And these are some technical terms about the uh, ground wave propagation. The first one is field strength at a distance. Radiation from an antenna by means of the ground wave gives rise to a field strength at a distance, which may be calculated by use of Maxwell's equation. And this is the formula. The field strength at a distance, its formula is 120 pi hi upon lambda d. If a receiving antenna is now placed at this point, the signal it will receive will be in volts. And this is the formula. The signal which will be received on the receiving end, its formula is given as follows: V equal to 120 pi h r h I L upon lambda d, I upon lambda d. Next is the sky wave propagation. Uh, Signal is sent by the transmitter, reflected by ionospheric layers, and received by the receiver. It is transmitted in either single hops or multiple hops. Let's discuss the reflection mechanism of the sky wave propagation. So, electromagnetic waves return to Earth by one of the layers of the atmosphere appears to have been reflected. It appears that the rays are being reflected by the ionospheric layers. In fact, the mechanism involved is refraction and the situation is identical to that described in the figure. So it is saying that it may appear that the ray is getting reflected, but actually the process of refraction is taking place. How? See, ionosphere is its density varies with height, and when the ray enters the ionosphere, it bends uh, it bends in this direction. It bends away from the normal, and it at each successive layer it keeps on bending until it becomes parallel. Uh, so it's saying that if the rate of change of refractive index per unit height is sufficient, the refracted ray will eventually become parallel to the layer. At one point, it will become parallel to the layer. It will then be bent downward, finally emerging from the ionized layer at an angle equal to the angle of incidence. And then, after becoming parallel, it will start becoming start bending downward. The critical frequency for a given layer is the highest frequency that will be returned down to earth by that layer after having been beamed straight up at it. It is saying that the critical frequency is that frequency. If we send a wave at that frequency, it will not escape into the outside the Earth's atmosphere and the ionosphere, and it will be reflected back or refracted back to the receiving end. There is another term which is the maximum usable frequency or MUF is also a limiting frequency, but this time for some specific angle. MUF equal to critical frequency upon cos theta. Another term is skip distance. The skip distance is the shortest distance from a transmitter measured along the surface of the earth at which a sky wave of fixed frequency, more than critical frequency, will be returned to earth. Next is space wave propagation. These are the waves with high frequencies, and its types are microwave space wave propagation and tropospheric scatter propagation. In this, uh, signal is directly transmitted from the transmitter to the receiver in the line of sight. In the space wave propagation, we have two receiving antennas. One transmitting antenna and a receiving antenna, and the signal is transmitted directly through the line of sight from the transmitting end to the receiving end. It happens at the first layer of the atmosphere, which is the troposphere. The tropospheric propagation, it happens, the space wave propagation, the first type we have the tropospheric scatter propagation, and it happens to the uh, troposphere layer of the atmosphere. So that was all about this presentation. Thanks for watching.